This
that we
conference
will
will
use.
now be recorded. This conference will now be recorded.
Okay, so we will be recording this session, every day's session, and I will share it with you in some cloud-based folder and keep it there minimum 24 hours, so that in case through this course, if you are missing some classes, so you will not miss the continuity. So with that in mind, we will do that. So it's 9 o'clock now, and we will every day, let's start 9 o'clock sharp, and I will take that much content which can be delivered in a 60-minute time frame. I'll not, because a lot of you are working and working from home, and a lot of people are telling that working from office is less stricter than working from home. So there are a lot of these daily status report meetings. People have to log in, all that. You have those issues. So I'll not um, uh, disturb you in the day-to-day activity. So what we will do is that we will take a content that is suitable to be delivered within 60 minutes. At times, to make a logical conclusion of a session, it might take plus 10 minutes or sometimes minus 10 minutes, but that is how we will do this throughout the course. So again, from a protocol point of view, please feel free to ask questions, unmute yourself and ask questions. And also, please feel free to type in your questions. I may not be able to see immediately, but by the end, I can see the questions and answer those questions. So let's get going. And first, let me thank you, everyone, to spend this time to learn this new upcoming topic. These days, everyone talks about artificial intelligence, machine learning, deep learning, and a lot of problems are being solved uh, in a good way for the businesses to really compete against their counterparts. And again, these days of Corona, COVID-19, again, we are talking a lot about these models, how models have kind of driven some democracies to impose very strict lockdowns, and then there's a lot of criticism about the pessimism expressed in the models. So whatever, we'll talk about those topics later, but people are talking about this technology, and this is a real technology. So we will spend some time, and my goal is to really share my knowledge of whatever I know. I'm not expert, I want to tell up front. In fact, I learned these topics with a view that we started a company called CloudScale QA, and our goal was to apply these technologies and build some models and predictions so that software testing workflow can be made more intelligent. Also, software test automation workflow is made more intelligent. Within that view, I started learning the course, but actually in my team, some people know much better than me, but I learned it. Uh, then I thought, okay, why don't we teach it also to the professionals who want to learn? And so in this lesson of 1 hour, what we will do is that I'll talk about the course, what we will learn through this next few days, and how this course will be different. And also, then for the first lesson part today, we will broadly understand what is this terminology, artificial intelligence, what is machine learning, what is deep learning. And a lot of times people are using it in a confusing way, and a lot of training companies too, they they actually confuse people. So what we will do is that we will try to reduce that confusion. And then third topic that we'll talk, we'll try to define in as simple terms as possible the word machine learning, because that is our goal, to learn machine learning foundations. So let me start talking about the course. So when I wanted to learn this course, some 2 years back, I started talking to some of the people who have learned the course, some people who wanted to learn this course. And when I asked how do they feel, some people talked about these things. Some people told, I started learning it, but then it is too complex. Maybe I'm not good enough in maths. That's why I may not be able to learn machine learning. That is, some people have expressed that. And some people have expressed that maybe I need to go back to graduate school to learn this stuff because it is such a complex theory. Maybe while working, it will be very tough to do that. Uh, I think my voice is getting resound. Okay, so hope you are able to hear me clear.
There's an echo, sir.
Madhu, we need to ask everybody to mute that side. Or if we could fully mute all the attendants, it would be great.
Yeah, please mute. Anybody who is sitting closer or something like that, try to mute it. Okay. So some people have told it is such a complex theory. While working, maybe I will not be able to learn. Maybe better go to a graduate school and learn this. And some people who have started learning by paying a lot of money, they realize that it will take a lot of years to master everything. So let's stop this learning and get into another field. All these kind of things I've heard from people who wanted to learn this topic, machine learning. And if you too have thought sometime, what I tell is that it is not your fault. Don't blame yourself. Who is causing this kind of thinking is actually a lot of courses, for good or bad. They are very obsessed to teach individual algorithms and actually teach upfront a lot of complex maths and theory. Or in fact, we classify these machine learning courses into two categories actually. One is an academic oriented courses, another is more practical oriented or applied kind of machine learning. So a lot of courses, especially taught by top class institutes, they are focusing on teaching it in an academic oriented way, or in other words, they teach it using what we call a bottom up approach. We are not saying that approach is bad per se, but for the first time learners, sometimes it can make everything confused. So actually in these kind of courses, there will be a lot of emphasis on mathematics and theory to start with, which is needed for machine learning. We are not saying no to that. And also they talk about a lot of depths of algorithms, even though practical machine learning doesn't require that understanding of depths of algorithms, because the Python ecosystem and other commercial ecosystems have created very high quality algorithms already, and they're all available to you to use it. Sometimes this academic oriented machine learning, they talk a lot about algorithms, and they may not tell how to apply in what kind of situation, how to tune an algorithm to get the right results. The practical approach sometimes lacks. That's what I too have observed going through a lot of online courses. And also, again, I'm not telling that those are wrong. Yes, that is also has a right place. And only thing is that if a fresh learner, first time learner, if they are bombarded with this kind of orientation, then they may get confused and they may miss to see a forest to tree. That's what we always tell. First you see the high level picture and then go into the details later. That will be giving understanding with less confusion. So that is what really we will try to do in this course. That's why I called it as a machine learning foundations course, and it will be more a practical course. It is going to be an applied machine learning course. I will not bombard you with a lot of details of algorithms and maths and theory. Why I will not do? Because I also don't know. But once we know the big picture and be able to build professional graded models, then we will be in a position to go into the details that we need to go and understand at that time, once we understand the broad picture. So that is what I will leave you with at the end of this course. So our course is not going to be a bottoms up approach, but we will use what we call a top down approach. So it is going to be an applied machine learning. It's a practical machine learning course. So maybe the first week, 5-6 classes, we will talk about some theory, because we need to understand the definitions, the terminology in a very clear way. And then we will build actually 4 projects using some readily available data sets using Python based tools. So as soon as the theory part is over, in fact, in these lectures of 1 hour, you will be sitting with your computer with a Jupyter notebook with Python tools installed, and together we'll be coding. Again, good thing about machine learning, unlike other programming models, we don't write thousands of lines of complex code. That is good part of machine learning. But still, we to build models, to organize some workflows, you need little bit of logic using Python. That's all we learn also as part of this course. A crash course for Python we'll do, and then move to the 4 projects. And while we are doing the projects, we will learn the concepts, theory, maths involved, but our focus will be to build a professional graded model from start to finish using a real industry strength process, so that it will be useful at your workplaces whenever you get this kind of project. So there will be no heavy maths and theory in our classes. We'll focus more on building intuition and around other key concepts. You will realize how we do that. And again, like typically in a lot of these academic courses, people, to solve a particular problem, there are many options are there. They teach every option, and finally they tell, out of these 10 options, these 9 options are useless, 10th option is the best. So what we will do is that we will not go to all 10 options. We'll go to the best practice option and learn that, because that will save our time. And if those options are not worthwhile, there is no point even learning them. That is how we go about in this course. And similarly, every lesson, as we start building the projects, will be coding session, will be going along with the lesson, and you will master to apply right algorithms right way at the right times. So that is what is going to be our goal. We'll not try to spend too much time understanding the theory of algorithms, because our goal is not to research on building new high efficiency algorithms. That is not our goal. If that is the goal, yes, we have to learn it much more in depth. That is also needed for some people, but this course will not solve that problem. And again, because we start applying first, later on building theoretical knowledge will become far more easier. As I told you, in this course we will do 4 projects, and through that you will learn how real data scientists, they apply machine learning algorithms effectively and efficiently. So I'm very quickly, again, all these things I will share it with you, so don't need to, again, these are all very self-explanatory. So our approach to this course, I'm calling it as the 4 project approach. So we will after initial terminology clarification and most important issues of machine learning, building projects, once we complete that theory, immediately we'll get into building projects, and we will do everything using 4 projects. But for the 4 projects, first we have to learn Python programming. So we will do that just before these 4 projects. Again, this Python course is not a Python course with a goal to make you all experts in Python and you all will be able to build very complex web applications using Python. No, it is not our goal. Our goal is to learn sufficient amount of Python and associated data science, data manipulation tools within Python ecosystem to be able to build professional graded ML models. That with that in mind we'll do. So it will not be a very long course. It will be a crash course to equip you to do the projects. And again, in the first project, what we do is that we will understand all the most important concepts of building ML models, the process, the metrics, the hyperparameter tuning, all that we will try to understand first using what we call a synthetic data set. It's not a real data set. Using some of the tools in Python called NumPy, we will build our own synthetic artificial data set and play around with that to build intuition into the most complex ideas of machine learning projects. And then we will move to the real, we'll take a real data set and solve from start to finish, applying a real good process to build first a regression model or a regression project. Again, don't worry even if you don't know what is regression, we'll talk about it. Then because in the machine learning, the 3 important classes of models we build are the tasks we really perform to solve prediction problems. One is called regression problem. So we'll solve that problem on a real data set using a industry graded process, so that if you learn those 25 steps that I will tell you to build a professional grade model, you can take that knowledge to any context within your company project situation and will be able to do that. And then I'll move to the project 3. Here again we'll take a real data set and solve a different kind of problem, and that problem we call it as classification problem. And again we do take a real data set and a real problem and try to apply a industry graded process and solve that. So basically the process of building models will repeat. So through repetition you will get more expertise in building models. And the 4th project will be to build an unsupervised learning task, and we typically call it as, actually the previous one is called the classification. Again, don't worry, even if you don't know what is classification, we'll clarify it. And the 4th project will be to solve a clustering problem. We'll build a cluster analysis on a e-commerce data set to build using that model a recommendation kind of engine. So that is going to be our goal. So while we do these 4 projects and understand the most important aspects of machine learning, we'll not leave it any important concepts. This course is designed for, again, beginners who are learning machine learning for the first time and want to get into those roles and also solve some problems currently your companies are trying to solve. And then, though it is a beginner level course, whatever you will learn these 4 projects, you will master the way professionals use. We will use proper approach to solve this problem, so that don't think it is all trial and error, something we have learned. No, we will be, if you really carefully understand, then solve more such problems. Take some data sets from Kaggle or someone and keep solving using the 25-step process. Then you will be able to do any problem. Again, it's not easy task. After this course, you will not be experts. Always in companies, machine learning work is a group-based activity. So a lot of domain specialists, a lot of senior data science specialists, project managers, customers, everyone will be involved. So you will be effectively be able to play a role in that kind of team. That is the goal of this project, this topics or this course. So first part I covered. I wanted to cover 3 things today. The first one is about the course. So anybody has any questions, feel free to unmute and ask your questions. So hope I am audible. Somebody can clarify that to me.
Yes.
Yes.
Okay. Okay. Fine.
Loud and clear,
So
Madhu.
now, very good. Thank you very much. Because sometimes if I'm speaking to my computer, I will get confused. So anyway, so now let's move to the second part of this today's lesson, where my goal is to clarify what is AI, what is machine learning, what is deep learning, because we come across these terms very frequently. And when I speak to some training institutes, sometimes they will tell, we will teach you AI. Then they will tell, we will teach you deep learning. Sometimes they are using a lot of terms. Machine learning is not AI, deep learning is AI, something like that. They confuse you. So my goal immediately is to solve that problem in your minds, have whatever clarity that we can arrive at. So just before getting into talking about what is AI, ML, DL, anyway, this is a little bit outdated report, but because a lot of things have changed with COVID-19 now. So sometime back, I went through Google and found this report from PricewaterhouseCoopers. They talked about and they were projecting artificial intelligence industry, how it will grow, and what can actually still stop AI growth even today in 2020. They were making some projections and asking a set of questions. So basically what that report was telling is that AI has a big promise, and they told that by 2030 AI will actually create so much of wealth, around $15.7 trillion of revenues can be generated using this technology. And 15.7 trillion is really big, at least during that time when PwC has talked. It is the combined GDP of China and India. I don't know what will happen to combined output of China and India post this crisis. And maybe post this crisis, what will be the projection for AI also is a questionable thing, but this is little bit dated. But then while projecting such a promise for artificial intelligence by PwC, they also talked about some things can hamper real growth of AI, and they talked about these 4 things. So I want you to also think along with me whether these 4 things can hamper the growth of AI even today in 2020. So what PwC told is that lack of compute power can be a potential roadblock for the growth of artificial intelligence industry. Do you agree or not with PwC? So like
Sorry,
when I
sir.
was studying
Are you, sorry to interrupt. Are you sharing
Ah.
something?
Yes, I'm sharing my screen. Are you able to see or not?
I'm not able to see your screen, so that's why.
We are able to see, Madhu, your screen.
Okay, okay.
Okay, so maybe you have a little bit of issue, please check it. But thanks for at least telling that. I'm sharing a screen. Okay, so
Madhu, now we lost your screen.
Now I have lost the screen actually.
Madhu's screen
okay,
gone.
okay, that's good. Thank you. I'll solve it. Just a minute.
Yeah.
Oh.
Madhu, can you share your screen again to me?
Are you able to see the screen now?
Yeah, now we
Yes.
got
Yes.
it, Madhu. Thank you, thank you.
Yeah, back online. Thank you.
Okay. Sorry. So let me continue. So basically, I was talking about this PwC thing. While they talked a great promise by artificial intelligence industry and the amount of money, but again they expressed some little bit of concerns and doubts because of some reasons. we may not see the real growth. Because why I'm talking about this is that there is a lot of hype around this AI, and people are learning, and actually the hype is a little bit real also. A lot of companies, a lot of new solutions are actually being solved using AI, ML, DL. A lot of wonderful solutions are happening, no doubt about it. But still, the 4 issues PwC talked below, they told potentially they can be issues. So they told lack of compute power, because if you look at AI, it is not a new thing. Around the time Charles Babbage has invented a mechanical computer, at that time also people were thinking about, hey, how can we make computers to think like machines and solve problems like thinking humans. That idea was there from the time a computer has been invented, and it has even Alan Turing and all, they published very wonderful papers at that time, how to make machines think. So artificial intelligence in a way is not a new thing that we are talking in 2000s and all. We have been talking from 1950s and 1960s also. But then suddenly it went into what we call AI winter, where people stopped talking about it. And one of the reasons at that time for AI to get into that AI winter is basically, though the ideas, the computational models were in place, but the power of computers was not sufficient. There was a huge issue of a lack of compute power to solve those problems, and that's why it went into a kind of AI winter, and then people forgot about it. But again, when in 1996, 2000s, suddenly actually some things have triggered. I think IBM has created a program that will play chess against people, and then a chess playing machine. They called it as, I think, Deep Blue, or I don't remember. But what they did is that they created a chess playing program, and that program, instead of like previously when I was studying or working very early in the days, whenever bosses are not around, we used to play a chess game on the computer. And a lot of times, because I didn't know much chess, I used to lose to the computer. But a lot of my friends who are good at chess, they used to beat the machines. But those early programs of chess were not AI-oriented programs. Whatever, because we understand the conditions in which chess game is played, people, good programmers, were able to solve that problem by writing complex logic and made those chess playing games. But then IBM has changed that, and they created a game which started playing with on its own with another set of programs, and then it started learning from the opponents, and using that learning, it started improving its game. And finally, one fine day, Gary Kasparov was invited to play against the machine by IBM, and whatever the news is that Gary Kasparov lost the match with the machine, and that has caused real hype again. Yes, machines can be made to learn on themselves, and then they can start helping in a lot of tasks. So then, because the compute power was available. But today, again, still we are telling the kind of data that we are having and the complexity, though we have a lot of cloud-based, parallelly, massively parallel computers and all that, still to solve some problems that we have today with our data, maybe today's compute power may not be sufficient. So that can be one potential bottleneck for even today AI to grow. That's why a lot of people are working on the quantum computing and all that to solve problems much more faster. And then the second problem is a problem we know, lack of people power. Though we know we can solve a lot of problems across industries, across business processes, a lot of data oriented, data driven solutions can be made, and they can really help humans to automate very intelligently. But then developing machine learning models is far more different to developing the traditional software applications. So people have to unlearn the whatever they know already doing traditional programming if they want to do machine learning based programming or machine learning model development. So there is a lot of amount of work, but there is less kind of people. That's why a lot of training programs are taking place, and also a lot of you also have shown interest to really look at this. Okay, then the third issue, PwC talked about machine learning or AI, basically not to pick up the momentum as they thought, is the third reason, that is actually inability to build trust. So basically now machine is learning data and making a prediction using which we will do a decision. Let's say I have a machine which is using a computational model called artificial neural network. Artificial neural networks are nothing but the computational models which mimic the internal workings of human brain. Using that, it solves a problem and gives output. Let's say I have 1,000 CT scans of 1,000 patients. I gave that input to a ANN model, a neural network model. Now the model has done something inside. What happened inside is a black box for me. I don't know. But then it gave an output out of these 1,000 CT scans. I asked, or I wanted it to automatically learn and tell me which of the CT scans tells that there is a cancer, and if there is a cancer, whether it's a benign cancer or a very dangerous cancer. So I gave 100 CT scans to my computer with this model running based on neural networks, and it gave an output that, okay, the scan 21 has cancer. It is a not so complex, it's a benign. So 97th CT scan has cancer and it is very, very dangerous. Who told this? Machine told this. If a doctor says that, we will ask question, hey, how did you come to that conclusion? Doctor is a white box. He will tell, okay, based on whatever his domain knowledge and expertise, he or she will explain to us. But a machine will tell an output, but if machine cannot explain it, then human societies will not build trust on those kind of predictions. So that can be potential problem for AI to grow in at least some areas, because all AI, that's why a lot of research is going on right now. Whatever AI we do, it has to be interpretable. Means somebody, it has to be a white box oriented. Yeah, whatever outcome came, decision or prediction, that came because of this thing happened within that neural network. Somebody should be able to explain. If we build such a complex AI using which some outputs can be produced, but nobody can explain what happened inside, then human societies will not accept. That is why inability to build trust is another issue, why AI still can face problems. That is what PwC was telling. But also another thing PwC told is that a lot of times by watching Hollywood movies, our vision about AI is all about some human-like machines actually doing everything like humans, and then actually beating humans in everything they are doing. That is what typically we call it as not artificial intelligence. We call it actually as human general intelligence. So again, the IBM's, the Deep Blue machine, whatever the chess playing machine, can beat Gary Kasparov. But if I tell that machine, hey, I will give you 3 voices, one of a female, one of a male, one of a kid. You tell me which voice belongs to whom. That is a very simple problem for us human beings. As soon as I listen, I will tell which voice is from whom. But to make a machine, because it played chess with Gary Kasparov, it defeated Gary Kasparov, so it will be able to do this simple task. No, it will not be able to do this simple task. In fact, making a machine to play chess extremely intelligently is far more easier than making a machine to recognize speech and be able to tell which tone belong to whom. So that's why what I mean by this one-track minds. Still, humans only can build machines that can be perfect doing only one task. Because it is perfect in doing one complex task, it doesn't mean that it will be able to behave like human beings. So whatever we see in movies, that is some thousands of years away from us. So that is also one of the things we have to take it out of your minds. Human general intelligence is still not possible to give it to machines. Even today, we can only do some things. We call them all this body of knowledge, we call it as AI. And one segment of those techniques, using data, you learn and understand the patterns and try to create models that can be used to solve problems. We call the techniques or group of techniques as a subset of AI as machine learning. And then within that machine learning, another subset of newer techniques to solve problems like speech recognition, understand the emotion in a textual things, and also understand vision, computer vision. These kind of things come under as deep learning. We'll talk about that, but we are not talking yet about. So basically what we are really talking, today's advances of AI, artificial intelligence, they do not bring the kind of intelligence that Hollywood movies are talking about, but they will actually at the moment are able to give one critical component of that intelligence. And what is that critical component of that intelligence? That is prediction. Like I have very complex data. Now I have I'm Amazon. I have billions of customers doing trillions of transactions every day, trillions of transactions. Now I want to build some intelligence using that data to recommend the relevant products to relevant customers. Okay, so I have to, the data is too complex, the data is changing too fast. I want to make an intelligent business process instead of promoting all products to everyone, which is anyway practically not possible. Relevant products to relevant customers, if I want to do, I need some intelligence. So how that intelligence comes? A prediction. If a ML model can look at the data and tell, hey, Madhumurthy in the last 4 weeks bought ML books and 2 home products. So now maybe for this Madhumurthy, let me recommend another good ML book with 5-star rating rather than iPhone. So first, that prediction has to be made by the algorithm that Amazon is using. Madhumurthy, out of these 4, he may more likely to be interested in a book at this moment. That might change to an equipment later, but right now it is book. So I can write remaining programs to only promote books related to machine learning to Madhumurthy. So that critical component of intelligence, to be able to look at the data, understand the patterns in the data, and be able to make a prediction is a very critical component of intelligence. And today's AI, ML, DL technology helps people to build that. Okay, so prediction is what really is the process of filling missing information. So basically, I have a lot of data. There is something in that data. I cannot write logic to solve the problem because that is too complex. I want my machine to learn that data on its own, understand that pattern, and give me that missing information to me so that I can more intelligently use that insight given by machine in my business. That is what is really the today's ML is using, and companies are actually the current software applications, enterprise applications, current products, mobile apps, which are collecting a lot of data. They solve some workflows, automating it. Now companies are trying to get this new capability of data-driven, prediction-oriented decision workflows into their current software workflows to make them much better, to give better services to their customers. That is why we are seeing the huge growth in this field called AI, ML, DL. So quickly, let me define. So when we are talking about AI, we are talking about a broad body of knowledge that wants to give some to make machines to think like humans and solve problems. How do we make machines to think and solve problems? That body of knowledge, we refer it to as AI. Okay, this has been there from 1950s. In fact, when I was studying also, my computer science students used to study this topic. So this is a broad body of knowledge, figuring out how to give intelligence that belong to humans to machines so that we can solve problems like humans. Then machine learning is subset of AI field, body of knowledge. And ML, actually what it does is that it looks at the data. Using the data, we should be able to teach computers so that on its own, a computer will figure out the patterns that are inside the data, and using that insight, it will help us to solve some prediction problems for some unseen data. I'm using some words, but don't worry. But machine learning is a subset of artificial intelligence technology. Again, machine learning is also not very new. Machine learning used to be called statistical learning. A lot of economists, statisticians, they always looked at complex data, and because complex data, what is really inside the data for a human mind, it is not very easy. So you have to apply some statistical techniques and mathematical techniques to understand the data and figure out a right pattern that is existing in the data. That has been there, and we used to call it as statistical learning. And the same field today we are calling it as machine learning, because only difference between statistical learning and machine learning is that in statistical learning, the data was static. We have one data which it is not changing every day, every hour, every minute. We take the data and figure out and build some models to understand the patterns in the data. That is statistical learning. The techniques are same, but when we call ML, what is happening is that the data is a continuously changing data, and it continuously computer learns using the changing data, and it keeps on updating its model. It is not a static model, it's a dynamic model, varies. Like for example, what happened in this corona thing, somewhere Imperial College of London has talked about very pessimistic thing about how many people will die, but then now they are projecting less number of people. So it is a model that changes with the reality of the new data coming in. So those techniques are called machine learning techniques. It's a subset of AI using statistical learning tools. It understands underlying patterns inside data to help us to make good predictions. So that is ML. And again, when it comes to DL, these are newer techniques. Again, some problems, as I told you, which are more complex for a computer than to a human, whether look at a set of pictures and tell which picture is that of a cat and which picture is a dog, or within pictures what sub pictures are available, or which voice belongs to whom, or automated driving car. These kind of things require much more complex techniques, and most importantly, that is where the artificial neural network kind of computation model, which mimics the internal workings of brain, and algorithms founded on that kind of computational model that mimics human brains way of working, and using those techniques to solve complex problems for machines but simple problems for humans. That new techniques we are calling, and that subset is called deep learning. So I want in your minds to make it very clear, AI is a broad body of knowledge, machine learning body of knowledge that attempts to give human intelligence to machines. Then ML, machine learning, is a subset of those AI technology and a subset of techniques which will take data and try to understand the patterns using statistical techniques. And then deep learning is another subset of machine learning only, which actually uses artificial neural network as a computational model and tries to mimic the human brain's way of working and solves some different class of problems that we're calling it as deep learning. So again, our goal in this lectures will be only on machine learning, and machine learning is further divided into supervised learning, unsupervised learning, reinforcement learning. Right now, don't worry. Again, we will in the next sessions we will talk about all this terminology with utmost clarity. So just again, in our class, we will be more focused on unsupervised learning and supervised learning only. We will not really talk about reinforcement learning. Again, in supervised learning, we do regression project, we do classification project, and again, in unsupervised learning, we'll do clustering problem. Okay. So anyway, before I conclude on what is AI, ML, DL kind of definition, I want to check your understanding. So if you are able to see my screen, just look at this on the right side. I have whatever I talked, the definitions of AI, ML, DL I put. What you have to do really is that you have to match them with the right side on the, with the right term on the right side. So you can follow me and give your answer. So tell me, a subset of machine learning techniques inspired by the information processing patterns found in the human brain. What are these techniques? They are artificial intelligence or machine learning or deep learning.
Deep learning.
Deep learning.
Great. Then the second thing is broad concept that consists of everything that can be loosely interpreted to mean incorporating human intelligence to machines.
Machine learning.
What is it?
Artificial.
Machine
Yeah,
learning.
it is not machine learning.
Artificial
It is a
intelligence.
broad concept that consists of everything. How to give human intelligence to machine. That is a broad body of knowledge. 1940 onwards or 50 onwards, we started calling it as AI. So that is AI. Keep that in mind. Okay. Anyway, third is very easy, but let us read it. A technology that enables machines to learn by themselves using the provided data and make accurate predictions. It's called
Machine learning.
machine learning. Where, again, data, we are talking about some data in numbers and values and use statistics to do that. That's we are calling it as machine learning. So we have talked about AI, ML, DL. Now we have another 10 minutes in which we will do a quick definition of machine learning, because our goal through this course is to really understand machine learning. We will not focus right away on deep learning. So machine learning. So let us define. So again, when it comes to machine learning, very complex definitions are possible. Like if you read university textbooks, they start with an equation. They will tell that if there is a machine M is able to do a task T with inputs D, then if this equation satisfies, then we can call it as machine learning. And that is very confusing and that is not worthwhile, at least in a practical machine learning kind of situation. It may be worthwhile in a different way. So we will not do that. So instead of that, we will do a very simple definition of machine learning. So how we will define, I'll keep on repeating through this course, this definition. So machine learning is the practice of teaching computers how to learn patterns from data. Why we want computers to learn patterns from data? To make predictions or decisions. That is how we are defining machine learning. So what you have to notice is that machine learning is the practice of teaching. I am not using programming computers. Okay, I am telling teaching computers. When we teach, what is the output that happens? Somebody will learn. So we are teaching computers using data and computer learns patterns inside the data, and because it learned, if it learns the pattern in a good way, then it will be very useful. I can ask a question to that computer, hey, tell me what should I predict based on this data now? Because you understood the data and I'm giving this data, you tell me the answer. We can ask the questions and get a prediction. So I'll repeat again, machine learning is the practice of teaching computers how to learn patterns from data, often for making decisions or predictions. So the keywords are here, teaching computers. And another keyword is patterns from data. Another keyword is making decisions or predictions. Okay. So again, you should not be confused with other kind of programming that we do. So for true machine learning, the computer must be able to learn patterns, and that it is not explicitly programmed to identify. Very important. So we are not programming the computer. Let me put a picture for you. Just let me show. Insert. Are you able to see a blank screen?
Yeah.
Yes.
Yes.
Okay. So basically, I'm writing now. Just tell me. I'm writing traditional programming model. All of us are experts on that. How it works? I have a computer. Okay. And to solve a problem, what I do as an engineer, I write logic, complex logic, which I perfected understanding Java, Python, whatever complex logic. And then I also have data. So I put the data that I got and I apply logic and solve that using a computer, and my computer will create a solution for me. If it is a understanding the patterns inside data, so I have a data and I built, breaking my head, a logic. Using that logic, it is making an insight. It is telling, this is the pattern that is happening, so you can use this pattern. That is a typical solution provided using our traditional programming model. So the logic here, we always develop using very complex rule-based algorithms. Hope my writing is okay. Okay, so this is what we call also now, in my slide I told, explicitly programming. This is what we use in our traditional software development. Okay, and we know this very well, and we are those who are good programmers. They understand these rule-based algorithms. They can write any logic to solve any problem very, very intelligently, and most of our software is developed, and this is the kind of software. But the problem is that in today's problems, the data is changing every minute. The data is too complex. No matter how good you are with your rule-based algorithms, you will not be able to really understand the true pattern that is existing in the data. Then it is not worthwhile. So the new kind of situation is forcing us to solve these data problems in a different way. So here, the ML model I'm calling, let's say this is my computer. Okay, I'm calling it as ML development model. So here, I'm not writing the logic. I'm only giving data to my computer. Okay, and I'm telling, hey computer, this is the data. I want you to learn from this data and figure it for yourself. what is the pattern that is there that can be very interesting for me to do some decisions and predictions in future. That is what I'm telling. But computer on its own cannot learn. We have to enable it to learn, or we have to train it. So how do we train it? We use a set of algorithms. We call them ML based algorithms or DL algorithms. Python has something called scikit-learn, keras. All these are already developed algorithms. So we select, choose those algorithms and tell computer, writing simple code in Python, tell that, hey computer, using this algorithm, using this settings of the algorithm, you look at the data and create your understanding and call it as a model. Okay. So computer will learn assisted by us using these algorithms and understand the data, good or bad, and creates a model. Now, how we use that? I'm a software engineer or a business analyst, then I will ask a question to my model, not to, whatever generated by computer. Already I gave some data, but I give new data now, not a data that is already used to train it. Some new, sometimes we call it as unseen data. And then the computer will tell a prediction. Okay, so let's take that CT scan thing. I have 1,000 CT scans. I gave it to the computer and I told, hey, learn using my some DL algorithms from keras or whatever commercial from SAS Institute. Then it understood and created a model. Now, I will give another new CT scan to this model, and it will tell no cancer, no problem, or another thing, it will tell cancer, benign, no problem, or for another one it may tell cancer, malignant. This, who is doing? The model is doing. How it is doing? It learned from some data that I have given. And if these predictions are as good as expert doctors in the world, then is it worthwhile or not? And if it is cheaper, because today, if anybody has to get real thing on cancer, people will ask 4 or 5 doctors and the experts are not available. They're very expensive. But let's say I have a machine that is able to do over a period of time of learning with more and more and more data, and it gained that kind of accuracy and perfection that it is doing as good as an expert human doctor, then we solved a big problem for humans. Okay, and that is where really we are using these things now. So hope you are able to see my screen now. I changed the screen.
Yes.
Yes.
Okay, so now already it's 10, but actually we will quickly because today logically we conclude with ML definition. So anyway, this is the definition. Machine learning is the practice of teaching computers. It is not programming computers. It is teaching computers how to learn patterns from data, and why we want computer to learn to make useful decisions or predictions. And for a true machine learning to occur, the computer is not programmed using rule-based algorithms, breaking our heads and putting our intelligence into algorithms. No, we are not doing that. If we are doing it, that is old way of solving problems. Then it cannot be called a machine learning. So that is, you have to keep it in mind. So to make it a little bit easier using some analogy, so there is a story called Candles, Stout Tops, and the Curious Child. So there is a curious child, 3-4-year child, doesn't know anything. Okay, one day there is a candle in front of her which is having a red and bright flame, and because she is a curious child, like every child, she just crawled up to that candle, and she was so curious she wanted to put her finger on top of that red bright flame. Then she has put her finger. Then what happens? It caused her pain. So basically, she got an experience. She got curious. She saw something red and bright. She put her finger and she got pain. Because of that experience, she learned. She got trained now. And though she is not very intelligent, so though she doesn't know what is combustion, what is thermodynamics, what are nerve endings, how they cause pain to the brain, all that complex scientific knowledge she doesn't have. But in spite of that, because of this training, she has learned and registered in her small brain one pattern. The pattern also called a model. What is the model she put in her brain? She told, oh, red and bright means it hurts. So then what happened? She got this pattern registered in her mind. Another 2 days later, she was in the kitchen and she saw this stove top. Again, this stove top was red and bright. So again, she was curious. She wanted to go. She went very close to that. And then she wanted to put her finger again. But then this model got built in her mind that red and bright means pain. Because of that model, she pulled her finger and saved herself. So what is happening here? It is machine learning. Through an experience, a pattern gets registered in a mind, and if that is a useful pattern, that can be used in a new unseen situations. Okay, so basically what happened here, let us analyze. The child, what happened? It learned patterns from the candle, that red and bright means pain. Now let us say the second day when she was going to the kitchen and almost put her finger on top of the red and bright stove top, her mother shouted, hey, don't put it. Then what is it? It is equivalent to explicitly programming. A programmer writing logic. If this, then that and that, or this and this, while this doesn't happen, don't do this. That is the logic. If she saved herself using that logic, then we call it as explicitly programming. But did it happen that way? No, it didn't happen that way. So she ignored the stove top because her parents told her, not because her parents told. That's why it is not an explicit programming. Hope you are getting it. So what we are telling is that machine learning is the practice of teaching computers to learn patterns from data to make predictions or decisions. And if you don't teach computers, you programming computers, that is not machine learning. So in machine learning, computers learn patterns from a set of data, and the data, we usually call it as training data. We'll come to all this terminology. So from the training data, once it learns the patterns, then it can apply those lessons. The patterns are also called models to a new and unseen data. So if you look at here, training data is the experience of putting finger on red and bright candle flame, and it has created a very simplistic model, and that has helped her or made a prediction. Hey, it hurts. So she has pulled her finger. So that is a new unseen data. So whenever we are talking about machine learning, there is a training data using which we'll teach computers. And then once a good model is created, we provide it new data, unseen data, to make predictions and decisions. If the pattern is registered in the right way, it will work. Sometimes let's say, assume the kid in her mind created a red and bright means pain. Okay, every time it may not be correct also. Let's say her dad bought a very red Ferrari car and it was standing outside her house. Now she looks at Ferrari, very red kind of car. She pulls her finger, then is it really going to pain? No. But the simplistic pattern that caused created in her mind will tell that red and hot means pain. But good thing about machine learning is that continuous learning happens. As new data arrives, new patterns emerge, the model adjusts itself to in a proper way, so that it gets more and more and more accurate over a period of time as it learns continuously. So that is what happens in machine learning. Okay. So again, machine learning is a very exciting field. So everyone is learning. So I'll be very quick. It is not a so it is disrupting entire industries. Agriculture is using it, healthcare is using, finance. No industry vertical is not experimenting with something around AI, ML, DL technologies. And within these industries, every business process is being automated using these data-driven capabilities, marketing, human resources, e-commerce. No business workflow is escaping from this. And again, a lot of new innovation is taking place today also. So it's a very exciting field for everyone to learn as testers, as engineers, as project managers. This is a very, very exciting field. So I have a set of questions you have to answer, then our class will be over. So you have to answer this question. So this question is, fill in the blanks, and the right things are there in the below, the right terminology. So you have to fill it with right things. First question I will read. Machine learning is the practice of teaching computers how to learn dash,
Patterns from
often
data.
for making
Patterns from data.
yes,
Decisions or predictions.
patterns from data, often for making
Decisions.
decisions or official definition. Yeah. The second one is practical machine learning. That is what we are learning. It focuses on dash and dash.
And
It's on
simplicity.
Intuition.
and simplicity,
Simplicity.
with a strong emphasis on results, whereas academic machine learning, which we are not learning the way, it focuses on theory
Theory and
and maths. And in no way we are telling theory and maths are bad. They are very important, but at an appropriate time, you can get into that and increase your understanding. So next question is a true and false, true or false question. So tell me which is a true statement and tell me which statement is false. So the first one I will read it for you. For true machine learning, the computer must be made to learn patterns by explicitly programming it.
False.
True or false?
False.
False. Everyone is clear. If you are explicitly programming it, breaking your heads, it is not machine learning. The second statement, I will read it for you. ML is disrupting entire industries and global business practices and will continue to reshape modern business and technology for the next decade. True or false?
True.
Third one is applied machine learning does not solve real world problems and it is not valuable. No, we don't agree. We learn using applied only, and then only we'll go and learn theory. Okay. The next thing is 4 statements. Again, you have to tell me true or false. So ML is application of advanced computer algorithms codified into machines through human intelligence. True or false?
True.
So I'll read it again. ML is application of advanced computer algorithms codified into machines by humans. If you are writing the algorithms and you are codifying into machine, it is nothing but explicit programming. I just change the words to confuse you.
False.
Okay. It is false. Machine learning is the practice of teaching computers how to learn patterns from data, often for making decisions or predictions.
True.
The definition. ML systems are based on sound statistical methods and they should continuously learn from data.
True.
So machine learning is actually an extension of statistical learning and it learns continuously from data. That's why these are categorized as a new set of techniques called ML techniques as part of AI. Fourth one, for true machine learning, the computer must be made to learn patterns by explicitly programming it. It is false. It is our traditional programming model. Okay. So recap, machine learning is about building models that can represent the world in some important way And if you build models, you will be able, if they are good models, we can make good predictions and better automate our tasks and make it easy for us. So there are a lot of algorithms. We are trying to do only one thing, that is help us to build models, the ML algorithms in scikit-learn, Keras, or whatever technology. All these things will help us to understand representations from the data. Machine learning builds models by learning patterns from data. That's what we told. Therefore, you can think of a model as an output of the machine learning process. So, in a traditional development, you write logic and generate is your code. Here, you do everything, finally submit to your team a model. That model will be integrated into your software by your customer or by your own product company. Okay, so that is what we talked about today. We are kind of 10 minutes took extra, but logically this is the time to stop it. So hope again you have any questions, please ask, or you can even write them to me and I will answer. So what I will do is that I stop recording as soon as we close. I think there are 21 questions. Okay. Uh, again, Meena, everyone. So what I will do, Meena, is that maybe I'll answer these questions tomorrow. Okay. I'll copy everything and try to answer them, because a lot of people may have to go for your whatever DS or your formal work. So please, if you don't, anyway, tomorrow I'll take your questions to start the session and then we'll start it. So at the moment I'll stop then. So again, our motto always is learn, have fun. So thank you very much. Bye bye everyone, and thanks for your attention.
Thank you. Good day. Bye-bye.
Thank you.
Very informative.